In the Pulsiv OSMIUM architecture, the function of the switch and the inductor is to provide sufficient charge to ensure the storage capacitor is charged from its minimum to maximum voltage. During the charging period, the inductor should operate in discontinuous current mode. The minimum charge time for the storage capacitor is when the grid frequency is 60 Hz, and this corner case can be used to determine the average current required to charge the capacitor. The maximum time to charge the storage capacitor is calculated when the voltage of the rectified grid is equal to the maximum voltage permitted on the storage capacitor. The Pulsiv OSMIUM microcontroller will determine the start of the charging process. The charge required to maintain the voltage on the storage capacitor is given by the following equation. The average current required is calculated using the following equation. From this, the peak current in the inductor is calculated using the following equation. To maintain discontinuous current mode, the inductor current must have a minimum of 0 and a maximum of this peak current during the two switching conditions: when the switch is closed and when the switch is open. In these expressions, the PWM frequency is set to 42 kHz and the duty cycle is determined by the Pulsiv OSMIUM microcontroller. The voltages can be estimated using these equations. From this, the inductance value can be calculated using this equation. The duty cycle values shown in this table are set based on different grid voltages and frequencies. The smallest inductance value from these calculations should be used in the final design. In order to ensure the current in the inductor does not exceed the peak value, a hardware-based overcurrent protection circuit is included. This prevents the inductor from saturating, and the recommended current sense resistor value is given by the following equation. The factor of 0.65 in this equation is the typical base emitter voltage of any silicon-based transistor. The threshold of the overcurrent protection circuit will vary as a consequence of this, and adequate thermal margins should be provided.